Hello everyone. So, in the previous video, we saw how to use the actuators. Today, we will make some projects using these sensors and actuators. So, today we are gonna make the fire alarm system, and here we are gonna use the gas sensor, more specifically MQ2 gas sensor. So, this sensor is sensitive to smoke gases like butane, LPG, propane, methane, alcohol, hydrogen, etc. So, whenever there is a fire situation inside any building, then there will be a lot of smoke, and that smoke will contain the lots of different elements. Okay, and we are gonna sense those elements, or in general the smoke, and accordingly we are gonna notify the user or aware the user of or ring the alarm so that everyone will get aware that there is some fire conditions. So I will quickly take you to simulation Tinkercad. So here I have the clean slate. So let's start by adding the breadboard. So as usual, I will use this breadboard setup. You can select the things separately. It's up to your choice. And let's start doing the connections. So first thing what we need for this project for fire alarm detection, some sensor, correct? Here we are going to use the gas detection sensor. Okay, great, my sensor came. So let's first do the sensor connections. So sensor connections are pretty simple. So all the lines or all the down terminals will be sorted, and we will give this to VCC. Okay, so from here to here, let's go from here to VCC. So instead of doing like this, we need to sort all three. No, I can simply sort it in like this. So in general, I won't be going deep into this MQ sensor, what all these terminals. I will just tell you whatever is necessary for the project, okay? And of course, some extra information. But if you want to go into the deep, I would highly recommend to go and check this sensor. And other point is right now I am doing the things in manual way. But in reality, in real life, generally you get the sensors in module form, where the higher level sensors like this gas detection sensor, you won't communicate it using the analog read. Instead of that, you will communicate with this sensor using the serial communication. So you may ask why you are not teaching us that right now. So simple answer is I haven't taught you serial communication yet. So once we complete those topics, I will again revisit and show you. Okay, no need to worry. Second thing is this A2 will go to our A0. Okay, so I'm just trying to get some straight lines. Let's change these colors. Yeah, if I didn't mention it previously, you can change the colors of these wires. And third pin from H1, we will connect it to the ground. Okay, now this pin is important. This pin determines the sensitivity of sensor. Okay, so I will connect some resistor here. Uh, let's bring it some more upward. Yeah, like this. And let's make it black color because it is going to brown. And from here, I will connect it like this. Okay. Okay, done. So I was telling about the sensitivity. So higher the value of resistance at this point, higher will be the sensitivity of this sensor. Okay. So using this resistor, I am controlling the sensitivity of sensor. Perhaps here connecting potentiometer will be better option. Correct. So I will not do that in this video. I will teach you using some other sensor. Okay. Reason calibrating the potentiometer in this simulation is bit difficult. Okay. Therefore, I will keep the real resistor only, and I can change the resistance value simply using this form. Okay. Now let's start connecting the actuators. So first thing I need is buzzer for alarming purposes. Correct. So let's search for buzzer. I got the buzzer. Let's connect the buzzer. Let's connect this to FD5 and let's connect ground to ground. Our buzzer connection is done. Let's make this green. After this, uh, I need some LEDs. So LED here, one is red LED in case of fire, and one I need is green LED. So no need to worry, I can change the color using this tab. Okay, I change it to green. Uh, so let's connect our red one to maybe 12, doesn't matter, right? And our green one to, let's say, 11. Now let's connect the resistors. So via the resistor, we will connect to the ground, correct? Let's reduce the resistance to 220 ohms. And I can select this, copy it, paste it. I got the exact copy. I can connect it here. Let's connect this also to the ground. Let's make ground connection black. Okay. So remember, while making the physical circuit also, try to use the different color codes. So it will make your circuit easy to understand. So whenever I see red wire, it means it is connected to the VCC somewhere. Right now we are making very simple circuits, so it doesn't matter. But in future, when we will make some complex circuits, this color quotation and small things will come handy. So I will, as usual, copy paste the code because code is pretty simple. I have shown you multiple times how to read the analog data, so I won't be repeating it now. So, and here I will show you one more beautiful thing about the code writing standards. Okay, so let me copy paste it. Here, if you see, the pins are different. Here for buzzer, it is 0. Assume if in the code, if I didn't define buzzer as 0, instead at every place wherever buzzer is there if I return the 0. Then for the minute changes also, I would have to go to every place wherever buzzer is written and need to change the number. But because I have defined it and given it the name, I can simply change here. I can say 5. For green LED, I can say simply 11. And for red one, I can say 12. Let's also print the value in serial monitor. Okay. So for that, what I will do, serial dot begins or begin only, my bad, 9600, that is bad, right? And let's print this gas value, serial dot print ln. And let's start simulation. Simulation started. Now let's come here. Let's minimize this. Okay, gas coming. There is no effect. There is no buzzer or anything. You may ask why. Let's look at the serial monitor. So I decided the high signal will be 600, but here maximum I am getting is 284. So you may ask, then this circuit is useless, correct? Actually not. So what we can do? Either we can change this to 600 to some smaller value, or I can simply increase the sensitivity by increasing this value. Okay, now see, when data, when smoke is here, value is higher. Let's increase this sensitivity even more. So let's make it 3K. Now see, sensitivity is even higher. Okay, see, and once it reach the 600, the buzzer is start buzzing. When it goes away again, when it come down, buzzer will stop. So I hope you understood this project and find this project interesting. So, and you learned how to calibrate the sensors, how to use the sensors and actuators together, and good practices while making the circuits and while writing the code. So that's it for this video. See you in the next video. Till then, bye.